Question 7. So referring to the spring mass damper of the system, write the relationship between force and displacement as a set of differential equations. Okay, so as we've gone through in the class, we know that the force due to the spring is equal to K times the displacement, and force on the damper is due to the damping times the rate of change dx by dt of the displacement, and force is equal to mass times acceleration, which is d squared x by dt squared. So that's the three differential equations. So if we had to put those together, we can say that the total force F is equal to md2 x by dt squared plus the damper b dx by dt plus kx. So that's what I want for the part A. Okay, part B. Assuming all the initial conditions are 0, write the transfer function of the ratio of x over f as a Laplace transform. Well, looking at the Laplace transforms with 0 initial conditions, then dx by dt transforms to sx, and d squared x by dt squared transforms to s squared x. Okay, so to write that as a Laplace transform in the form of x over f, we just replace the d's, dx's by dt's by s's. So then we can get the output x over input is equal to 1 over ms squared plus x sx plus kx, like that. Okay, part C. Okay, this is a bit more of an interesting one. We have mass values, damping values, and spring values. And we say if it's given a input of 5 newtons, then calculate the equation for the response on the x position versus time. So we need something that involves the x position and the time position. Okay, so we have the transfer function, which is by putting the values of m, so that would be s squared x, b is 5 plus 5sx, and k is 6 plus k, like that. And we have a step input to excite the system. So if we have a step input, it's basically a unit step input is 1 over s. So something over s, but it's not a unit step input, it's a value of 5 newtons as given in the question. So it's 5 over s, excites the system, and we need to have a look at the output of that. Okay, so what we're going to do is get the inverse Laplace transform, which will take these values and turn it into the time value. Okay, and to do that we need to separate the variables so it then matches the Laplace transform values. Now the Laplace transforms state that you can convert a value a over s, which would just transform to a, and also a value of s plus a transforms to e to the minus at, and that's our time element. So those are the two inverse Laplace transforms that we need to work with. But to get this into the form that we can see here, we have to separate this out and have plus signs between each one. Okay, so let's start to have a look at this. So we can say that x is equal to 5 over s times, and let's factorize this. Okay, so we have s plus a number and s plus a number here. Okay, and just looking at this, we can have s plus 2 and s plus 3. Factorizes it quite nicely. Okay, now we need to separate that to be able to get it into the response of additions and then be able to use the Laplace transform. So that's going to be some value over s plus b over s plus 2 plus c over s plus 3. Now we can use a quick method, which would be the cover-up rule. So if we want to find a and go back into the equation here, so we've got we have a times b and c here. So if we have to just find the value of a, basically we'll let s equal 0 here. So what we can do is, just going back to this equation, we can knock out that, so we're covering up that value, and we have 5 over 0 plus 2 and 0 plus 3. Okay, back into here. So that gives us a value of 5 over 6. So a is equal to 5 over 6. If we want to find b, similar method, going back to this equation, and what we'll do is, so b is s plus 2 here, so we can knock out that one, bringing this one back in, okay, and we'll let s equal minus 2 to take it out of the value. And then what we've got is 5 over minus 2, and we have minus 2 plus 3. Okay, so b then becomes minus 5 over 2. And then similarly to find c, okay, we're going to take c out here, so s is going to be minus 3, so s equals minus 3, back into this equation, so we have 5 over minus 3 into minus 3 plus 2. Okay, and then we have c is equal to 5 over 3. Okay, so again, working with all of this, we can then put that back into the equation. So what we've got then is, let's just sort this out here. Okay, so we've got 5 over 6 over s minus 5 over 2 over s plus 2 plus 5 over 3 s plus 3. Okay, now to transform that, we use the inverse Laplace transform. So a number over s just becomes the number itself. So that would transform to 5 over 6. Now we've got s plus 2, so we have the constant that we can take out, so that's minus 5 over 2, and s plus 2 transforms to e to the minus at, so that would be minus 2t. And then again we can take out the constant there, plus 5 over 3 e to the minus 3t, like that. So what we can do is we can put values of t in here and find out what x is equal to at different points on the equation. Okay, so we've done part C. Just to go to part D very briefly, it says compare the equation to the standard second order equation. Okay, so we've just going back, we have it in this format, and find out what the damping value and natural frequency of the system is. Okay, so for the values that we've been given, we actually have x over f is equal to 1 over, mass is 1, so it's s squared x, and then b is 5, so it's plus 5sx, and k is 6, so it's plus 6. Okay, so comparing that, we can see that the natural frequency, omega n squared, is equal to 6. Okay, so we can also see that 2 zeta omega n is equal to 5. Okay, so just solving for that, we know that the omega n is the square root of 6. We can solve for zeta by taking 2 over to the right hand side, and we should get omega n is equal to 2.45 and zeta is equal to 1.02. Okay, now just going back to the final question, which is if t is equal to 1.5, if t is equal to 1.5, and this is part E, by the way, calculate the x position. So that calculate the x position at t is equal to 1.5 seconds. So what we do is we go back to the equation that we solved just before d, and x is equal to 5 over 6 minus 5 over 2, which would be e to the minus 2 times 1.5 plus 5 over 3 e minus 3 times 1.5, just like that. And that will give us a value of 5 over 6 minus 5 over 2 times, let's get this right, 0.04978 plus 5 over 3 times 0.0111, okay, which would be 0.72 is the answer.